Hey, welcome back to Hipster Codes. This is Hipster GW. We're going to go over some more Python basics. In the last video, we went over basic data types as in strings, integers, floats, booleans, none type. I think that might have been it. Maybe there was another one I'm not thinking of, but I want to go over the basic data structures in Python. Not like advanced data structures, but just basically if you have multiple pieces of data, there are a handful of ways to store them in basically a single object, single variable that you can assign these to. But we have list, tuples, sets. They all have advantages and disadvantages. They all have their specific use cases. So I want to go over what the differences are between them, what some of the methods are whenever you utilize them, and how to loop through them as well. And then that might help you make some better decisions if you're just learning the basics of Python. So we'll start with a list. And so lists, if you've been in JavaScript or anything, this is basically an array. So the two key aspects of a list is that they are mutable and ordered. So what do we mean by mutable and ordered? Well, mutability means that whenever you assign data to the structure, data to this list, it can be rearranged, it can be taken away, more data can be added. So the list itself is mutable. But it is still ordered. So whenever it exists, you can loop through it, and every time you loop through it, you will get the same elements in the same order, assuming you haven't mutated any of them or rearranged the list or something like that, which means that you can also access them by their index. So let's look at what a list looks like. So we'll go here and create my list. They're going to use the square brackets in Python, and you could put pretty much any data you want in here. We could put numbers, 1, 2, 3, 4, 5. You see everything separated by commas. You don't have to have the space, but I always do just for that sake. So you could also put whatever data you want. You could put, element 1, element 2. They also don't have to be the same data type. You could go here. Whoops, I had an extra comma there. You can put an element 1 and then a number and a float. Hold on, my virtual machine's being a little slow today. And a float. So let's do an example. Let's do movies. So let's do the Harry Potter movies. So we'll do Harry Potter and the, how do you spell it? Sorcerer's Stone, because we're in America and it's not Philosopher's Stone here. I probably didn't spell it right. Sorcerer. I think I spelled it right. So that's the first one. Harry Potter and the Chamber of Secrets. You know what? I'm getting kind of tired of typing Harry Potter and the over and over again. So I'll just do Sorcerer's Stone, Chamber of Secrets. And also I'm going to turn on word wrap because I didn't have that on previously. Where's it at? Then it'll go on to another line whenever I get to the end of over here. Prisoner of Azkaban. Is there an H? I think there's like an... Oh gosh, I have to look it up now. Hold on, let me look it up. There is no H. I was spelling it correctly the entire time. Azkaban. Goblet of Fire. Order of the Phoenix. I should have chosen a longer one. Should have chosen Indiana Jones. That would have been good. Half-Blood Prince. And the Deathly Hollows. Oh my gosh. I'm terrible at typing whatever I have to do it in front of during a recording. Okay, so we have our various elements here in the list. So in order to loop in Python, we could loop through and print out each element at a time. We could print the entire list. And as you will see, if we print the list and we run our script down here, let's do Python 3main.py. My list is... I did the wrong name. You can see we get them in the same order. if you ever want to have like each element show on a different line, you can always use pretty print. It's standard library. No, thank you, Ubuntu. I will restart later. So we say from pretty print, import pretty print, and we could pretty print this. I hate the name, but it's a very useful library. Makes it a little bit easier to read. So we could look at it that way, or we could loop through. So we could say for element, but we're going to give this a name. So I'm going to say for book in my list. Not a very descriptive name for the list itself, but we could print out the book. And now you'll see it will go through each element. There's an indeterminate number of elements inside the list. It could be 1,000,000, it could be 1, it could be 0. It'll go through each element and then execute this code. So we're going to actually print out each element itself. Pretty straightforward. So you can also mutate the list, which means you can add elements. So we could go my list, and then to add an element to the end, we'll do append. And so we could add the cursed child. Let's see, does that count or does it not count? That is the debates between fans. And you want to not delete the previous statement. And now you will see it was added to the end. We could also remove an element. So you can see we printed it out. Let's go below this and let's remove. I don't know. Let's say that we want to remove the cursed child. So if you use the .remove method, you have to give it the element that you actually want to remove, the value of the element that you want to remove. Or if you save it to a variable, you could do that as well. And I need to reprint. Let's just print the list. Let's print. It's pretty print. My list. And we will do that twice. So now we are appending the cursed child, printing the list, removing the cursed child, reprinting the list so you can actually see we added it to the bottom and then we went and removed it. So you could do that. You can also use the pop method. The pop method does not take the element itself as an argument. You can call it like so. You're going to invoke it, and what it'll do is remove the last element in the list. So you see we actually got the same result. But you can also give it an index. So what are the index numbers? If you don't know this, index numbers are an integer position beginning at 0 of the elements in your list. So this is 0, this is 1, 2, 3, 4, 5, and 6. So there's 7 elements, 7 numbers, but 0 is the first number for the index position. So if we wanted to remove Half-Blood, or let's Chamber of Secrets, we'll put in 1 because it is the first, the 1th index. So we're going to pop that off, and then you will see the cursed child remains. However, we no longer have the Chamber of Secrets. We removed it. The difference between remove and pop is pop also returns the element that you remove. Remove just executes the function and just removes the element. Pop removes the element and then returns it in your code. So we could say my popped element. Oh no, I'm terrible with names. Don't blame me. And we already got to see what that looked like. So now let's print off. Let's print that element. And you see, we actually got Chamber of Secrets. How do we get Chamber of Secrets? Well, we removed it with the pop method. It removed this from the list. If we had printed the list again, it wouldn't have been there. But then it returned it. So whenever you get a return, you could then save that to a variable. We printed off the variable. We actually got Chamber of Secrets like so. So that's the basics of lists. There are a lot more things you could do with them. You can actually whenever you're looping through. You can loop through in reverse. You can index in reverse. You can splice lists. There's a lot of different things you could do with lists that I'm not going to go over entirely in this video, but there are also a lot of other methods too that you can use to mutate the elements inside your list, which is what makes them really powerful. So I'm going to get rid of all that code. And now let's go over tuples. Thing to keep in mind about tuples is that they are ordered and immutable. So you cannot mutate a list. So let's say, or I'm sorry, you cannot mutate a tuple. I misspoke. So we'll say my tuple. Tuples have the parenthesis signs. I'm just going to copy and paste the same information into it, but it also is ordered. So every element is in a specific order. You can put any data type you want. So you could mix and match, strings and integers. There aren't a lot of use cases for that, but maybe, there are times where you might want to do that. So it looks very much the same. You can also loop through it just the same. So you could say for book in my tuple, we could print out the book itself. Let's clear out this, and as you would imagine, it's starting to look pretty much the same, except we want to use Python 3 because I haven't aliased Python on this yet. So you can see we get all the different books. I just don't have a lot of room on the screen, but there is Sorcerer's Stone up here. So we get all 7 of the books. So cool. Looking pretty much the same, not a lot different. Let's try and append a book to it. So we're going to go mytuple.append. We can try the cursed child again. So let's once again now run the script. Oh my gosh, attribute error. Tuple does not have a pin. This is the immutable part of it. So whenever you construct a tuple, whenever you draft it up inside your code, you're going to add elements to it, and then you cannot remove or add new elements. You cannot manipulate, you cannot rearrange the elements within the list. So they're going to be ordered, but once the tuple is created in memory, it's not going to be mutated. So you can't append, you can't remove. What you can do is you could splice it. So we could say, let's print out a spliced tuple. So we'll splice it and get the first 4 books. And, if we print this out, you see we got Sorcerer's Stone, Chamber of Secrets, so on and so forth. And then instead of printing this, we could assign this to the variable mytuple. And then we'll print out mytuple before and after. So you see we create mytuple, we print it, we're going to splice it, assign it to mytuple, print it again. And as you can see, it looks like we actually mutated it, but we did not mutate the tuple itself. What we did whenever we spliced it was we created a brand new tuple. We never manipulated this tuple. What we did was we created a brand new tuple and then assigned it to the same variable name. So if instead we did mytuple2, and then instead of printing it before and after, we printed mytuple and mytuple2, what you will see is we have 2 entirely different variables, 2 entirely different tuples assigned to 2 variables, I should say. You can reassign the variable name, but that doesn't mean that you're actually mutating the tuple. It means that you're creating a brand new one and then just reusing the variable name. So that's just a quick note on mutability. One more quick note. If we wanted to add a list inside our tuple, what are lists? Are they mutable or immutable? Lists are mutable. So if we wanted to create a list, what would we put in here? I don't know. This isn't going to be Harry Potter related. I'm not thinking a lot right now. I can't think of good examples. Don't blame me. Blame movies. I don't know. So we're going to have John Wick 1, 2, and 3. So if we go in here, you see we cannot remove the last, we cannot actually remove the list, so we could try and do this, right? It's going to yell at us again. See, it yells at us. You can't remove, you can't pop, you can't append, right? But what you can do is you can access it by its integer or by its index, right? If you access it by its index, remember I showed that with the list by getting it with the Chamber of Secrets by the first index. You can access it by its index. So we could say my tuple square bracket, get the index of this John Wick list. So this would be 0, 1, 2, 3, 4, 5, 6, 7. The 7th index, if we print this out, what will we get? And also let's print the type, because this will hopefully drive the point home a little bit. So we're going to print the type. So we actually got the type is a list, and it's the element itself. So we can't mutate the tuple, which means we can't rearrange the elements. But if the element itself is mutable, aka if it's a list or something that's mutable, we could access, here, let's print out my tuple. Let's pretty print my tuple. We could access the element itself by the index. So we'll say my tuple at the 7th index. Also, because you can negative indice, we could say the negative first index because it's the last in the tuple. And now we're accessing that element, and that element's data type is a list. Treat each data type the way that it wants to be treated. Lists can be appended to. So we could append John Wick 4. And now if we pretty print our tuple, we did not get an error because we didn't break the mutability of the tuple. We mutated the list inside the tuple by adding John Wick 4 to it. So that's just a quick note about mutability. It doesn't mean you can't change stuff. What it means is that the elements, whenever you assign them to a specific position inside the tuple, they can't be removed, added to within that specific tuple itself. But if it's mutable itself, you can mutate that element. And you could manipulate the tuple by creating a new tuple. I should restate that. You could create a new tuple that looks very similar but is slightly different and then assign it to a different or the same variable name. But none of that breaks the concept of mutability or immutability whenever we are regarding our tuples specifically. I am having trouble with how small the screen is. So that's the basics of tuples. One more example. We'll go over sets. Actually, we'll do dictionaries in another video because this video is going to be getting long pretty soon. So we'll say my set. Sets are going to have the curly braces. And then I'm going to go ahead and include all the Harry Potter movies. I'm going to take away the John Wick movies for posterity. So let's include all the Harry Potter movies. So before I print it, because we will pretty print my set. Before I print it, what you have to keep in mind, sets are mutable and unordered. Oh, they're chaotic. They're the chaotic neutral of the Python of the Python data type world. So let's go ahead and print off my set. So what happened? Oh my gosh, we have Chamber of Secrets, Goblet of Fire, Sorcerer's Stone, and Deathly Hallows are all, what the heck happened? It looks like it randomized it. I don't have a perfect understanding of what's happening under the hood. I don't think it's randomizing it necessarily. Like, it's not running it through an additional function just to switch up the order of things. My understanding is that sets just don't care about the order. So it's going to access these elements in whatever way is fastest for it or most efficient for the functionality of Python to get it in RAM. Now, of course, RAM stands for random access memory, so maybe there's some randomness in there. You will occasionally find that elements will remain the same, or you'll run this twice and it'll be exactly the same. That could be luck. I'm not always sure exactly what's going on, but it's more about that it doesn't care about the order. So if you need some sort of data set or data type where it has to be ordered, you want to steer clear from sets. However, you could still go and loop through it. So we could say for book in my set, and we could print out the book. And you'll see it's just going to print it in different orders every single time. Was that the same? No, that wasn't the same. It was slightly different. So you could still access each element inside it. But there is one more. Oh, here, before I do the last thing, you can also add to it. So we could say myset.add. And so we're going to add the cursed child. Ignore that. There we go. Now you see the cursed child is there. I think it's just, it's like still accessing it in the same order because we haven't manipulated much in RAM, but you'll see it sometimes as you'll print it back to back and it'll be completely different, or times like this where it's exactly the same. Again, if you want a deep understanding, you'll have to do your own research on how it actually accesses this information. But if you want to add, again, adding is the concept of adding it to the set. Appending is appending it to the end of a list. So that's why it's a different word in set with the .add method as opposed to the .append method for a list, because it's a different concept. You can remove as well. So we can remove, the Deathly Hollows. So you can remove it. Notice it's not there anymore. But you can't use the pop method, right? Because the pop method requires, am I a big liar? Okay, this is new. I thought it wouldn't work. Apparently it just removes a random one. But, okay, I didn't think you could use the pop method. But you can't access things by their index, right? So we're going to try and access something by the index. It says a set is not subscriptable. Okay, apparently you can use the pop method, or I don't know, I was doing something weird. But you can't you access things by their index because that implies that there is a certain order to the data, and there is not. So you can do certain things, but not everything. One specific thing is not only can you add elements to them or remove them and they're unordered, but also each element is unique. So what do I mean by that? So let's try and add. Again, let's try and add the cursed child again. Again, I did append. Like I said, you can't do append, you have to do add. So there we go. We have the cursed child. Let's try and add the cursed child twice. Now, if we were to append this to a list twice, you would see two new elements be created at the end of the list. But we're not dealing with the list, we're dealing with the set. You notice there's only one cursed child here because each element is unique. You can try and add the exact same element with the exact same value over and over and over, and it's not going to work. That's just a facet of a set, is every element is unique in Python. So sets are often, if you're ever doing like code wars or some sort of challenge like that, sets can often be useful for those sorts of situations. So if you need to have multiple values over and over again in the data structure, you don't want to use a set. However, if each value being unique, if that's something you need, a set might be a good use case for you. So they're often used in a lot of different code challenges because you might have like get all the specific letters or something like that in a string. You could include it in a set, find all the different letters because it's not going to repeat each letter or something like that. So those are the benefits of a set, is you can add and remove elements. They are unordered, and each element is unique. So that's what makes a set unique. Again, lists are mutable and ordered. Tuples, here we go. Tuples are ordered and immutable, or immutable and ordered. And these are mutable and unordered, and each element is unique, is what a set is. So I'll go over dictionaries another time because they deserve an even longer video most likely. But hopefully these are a little bit clearer to you. If you have any questions, please leave them in the comments below, and I'll see you around in the next video. Peace out.